Okay, this is section 2.6. We're looking at other types of equations. So first we'll look at rational exponents. And rational exponents are exponents as fractions, where the numerator or the top number is the power and the denominator or the bottom number is what we call the root. Kind of like when we say square root or cube root. We're talking about that kind of root right there. We can solve equations in which a variable is raised to a rational exponent by raising both sides of the equation to the reciprocal of the exponent. Reciprocal just really means you're flipping the fraction that they gave you as an exponent. So the reason we raise the equation to the reciprocal of the exponent is because we want to eliminate the exponent altogether with the variable term, and a number multiplied by its reciprocal is always 1. So say we took 2 thirds times its reciprocal, 3 over 2. Well, the 3's canceled, the 2 canceled, and you're left with 1. So what we would have is a variable raised to 1 instead of a fraction. Now there's a lot of different ways you can write a rational exponent, or for an expression, for a variable, or for a number, any of these. Now what you're going to do is, here's your either exponent, or sorry, not your exponent, but your expression or your variable or your number raised to your rational exponent. And here's your rational exponent right there, the m over n. And you could change it to this or this or this format. Now, what I would use is, I wouldn't use this form right here because you're going to have a very large number. What I would do is I would use this right here. First, you would take the nth root of whatever number that is, and then, so that would make it a smaller number, and then you can raise it to m. Otherwise, here, you're going to raise that number to m, have a very large number, and then you have to take the nth root of a very large number, which that might get a little bit difficult to do. Okay, if you have an even root of a positive number, you're going to get two answers, one negative and one positive. If you have an odd root of a positive number, and it's talking about a positive number on the inside of under the radical. So if you have an odd root of a positive number, you will get one answer. Do not attach the positive or negative when working with odd roots. So let's take a look at this one. So we're going to take the x raised to 3 over 2 equal to 125. And to both of these terms, I'm going to flip the rational exponent, which is the 3 over 2. I'm going to make it 2 over 3 and do this to both sides. Now notice my 2's will cancel, and if I write it just a little bit different, if I write it like this, notice my 2's cancel, they go away, and my 3's cancel, and now I have a variable raised to 1. And remember, if it's raised to 1, we usually don't write it. Okay, so now this right here is a power, and this right here is a root. So we are looking at the cube root of 125, and then we're going to square that number. So remember, we're going to use this right here, this one right here. I'm going to cube it, but I'm going to take the nth root first, and then I'm going to raise it to the power. So the cube root of 125, and then whatever that number is, I'm going to square it. Okay, so I need three numbers that when multiplied together will give me 125. Now 5 times 5 times 5 is equal to 125. Now I want three numbers because I'm looking for the cube root. Okay, so I found three numbers. So the cube root of 125 is just 5. And then what we're going to do is we're going to square that number. So we will have 25 as our final answer. Now notice I didn't put a plus or minus sign in front of the cube root because over here it says if you're working with an odd root, so we have cube root of a positive number, our number was 125, you will get one answer. We got 5. Okay, and then what we did is we squared it because of this power. Okay, so notice we're only supposed to get one answer when we're working with odd root, and that's what we got. Okay, let's try this one. So just going to rewrite it, and then we're going to flip that fraction to be 3 over 2. So our fraction goes away. Now I have x raised to 1, or just x. And now I have, okay, so this is the power, and this is the root. So I have the square root of 16, and then whatever that number is, I'm going to cube it. Now notice I've got a even number for my root, so I am going to put the plus or minus in front of that. So plus or minus, and then the square root of 16 is just 4. So I have a positive 4 and I have a negative 4. So let me break this up. So I have x is equal to positive 4, x is equal to negative 4. And then what I'm going to do is I'm going to cube both of them. Okay, so 4 times 4, and then times another 4. That's going to give us 64. Okay, let's work with a negative. Negative times a negative is a positive. A positive times another negative is a negative. And then 4 times 4 times 4 is 64. Okay, so our answers are 64 and negative 64. Okay, again, so because we've got this even root, we should get 2 answers for our solution set. Okay, so even root, ours is squared. For a positive number, our number was 16. We got 2 answers. We got a positive 4 and a negative 4. And then what we did was we cubed that number, or both of those numbers. Okay, now let's look at not just x raised to a number, but an expression x minus 1 raised to a number, and that number being this fraction 3 over 4. So x minus 1 raised to 3 over 4 is equal to 8, and we're going to do the same thing. We're going to flip it 4 over 3, 4 over 3. Okay, so this fraction goes away. Now I have x minus 1 equals 8, and we'll go ahead and write the cube. So this is the power, this is the root, so we have the cube root of 8 raised to 4. Okay, I need 3 numbers that when multiplied together will give me 8. 2 times 2 times 2 gives me 8. So the cube root of 8 is 2. And then we're going to raise 2 to the 4th power. So 2 times 2 is 4, and then times 2. 4 times 2 is 8, and then 8 times another 2, that'd be 4 2's multiplied together, that would be 16. So we got x minus 1 equals 16. Add the 1 to both sides, so x equals 17. And that is our final answer for this one. Okay, now let's solve equations using factoring. So when we have an equation and it has polynomials of degree that's higher than 2, we can try to solve them by factoring. Okay, we use factoring when we were looking at quadratic equations, but we can use this for a whole bunch of different types of polynomial equations. Okay, this is what the technical term for a polynomial of degree n looks like. It looks like this right here, where the a sub n is basically just some coefficient, some number, and n is just a positive integer. It's really just any type of polynomial, and this is just saying that n can be raised to any number. So it could be like 7x raised to 103 plus, and you just keep on going down until you have a constant. Setting the polynomial equal to 0 gives a polynomial equation, whereas if it's not set it to 0, it's just called an expression. But when you set this thing to equal to 0, well, now it's a polynomial equation. Okay, and the total number of solutions, real and complex, or real and imaginary, to this polynomial equation is equal to the highest exponent n. So if my highest exponent n is 103, I should get 103 solutions, whether real or complex. So let's look at this one. So first off, what I would do is I would move the 3x squared over to the other side. So number one, I could set it equal to 0. And number two, I'm going to try to factor out x, as many x values as I can. So I get 12x to the fourth minus 3x squared is equal to 0. Looks like I can factor out a 3 out of both of them and an x squared. So I'm left with 4x squared minus 1 is equal to 0. Okay, now going to divide both sides by this 3x squared. Actually, just by, sorry, you don't ever divide by x like that. Just by that 3. And now I have x squared, 4x squared minus 1 equals 0. Now I have two things multiplied together, and they're giving me 0, so I can use the zero product property. So that just means pull them apart and set them both equal to 0. And then solve. So I'm going to square root both of these. So technically you should get a plus or a minus here since we're squaring or square rooting them. But 0 is neutral, so it doesn't have a positive or a negative, so it's just 0. Now I'm going to add 1 to both sides here. 4x squared is equal to 1. Divide by the 4. So x squared is equal to 1/4. Going to square root. So x equals square root of 1 over the square root of 4. And I need to put a plus or minus for here. Square root of 1 is just 1. Square root of 2 is, or sorry, square root of 4 is 2. Okay, now notice my highest degree was 4. Now because of the 0, we kind of lost one. Otherwise we would have had a plus or a minus 0, but since 0 is neutral, we just had just 0. Okay, and then I have a positive 1/2 and then a negative 1/2. So that would have given me 4 answers. But our final answer would be 0, 1/2, and negative 1/2 for this one. Okay, now when I see 4 terms, and I have 1, 2, 3, 4 terms over here, the first thing I think about is factor by grouping. So I'm going to group the x cubed plus the 2x squared. And I'm also going to group the negative x and the negative 2 together. And then I'm going to try to take out the most that I can from each of these two groups. For the first one, looks like I can take out an x squared. So I'm left with x plus 2. And the second group looks like I can take out a negative 1. So I'm just going to write negative right here. You could write a negative 1, but it's already assumed. So that would be x plus 2. I'll leave the 1 there. So then notice that both this group and this group right here, so this group and this group, both of them have the same term, x plus 2, so I'm going to factor that out of both of the groups. So what you would get is x plus 2, and you're left with x squared minus 1 equal to 0.